Okay, now it's time to start with our session of today. It's about digital transformation of 3D measurement processes. That's quite a long title. It's also a lot of technology. It's a lot to talk about as well. And we're going to talk again with you, Ajith, and also with you, Mark. But first of all, Ajith, first introduce you. What are you doing actually at ASML?
Yeah. So hello everyone. I'm Ajith. I'm a supply quality engineer at ASML, and my main role is to make sure that designs, complex designs, can be industrialized and produced at suppliers for volume. And so I'm basically in between the designers and suppliers to make the designs come to life. That's basically my role. And I also spend some time on the 3D PMI project, that's the MBD project, where I'm helping transition into a model-based definition environment for all our designs and being the main point of contact for suppliers.
If we're talking about model-based definition and what you are doing, what part of your job is first article inspection? I hope you inspect more than only the first article, but what is it?
Yeah, so part of industrializing the parts, we use different quality control methodologies. FIE, or first article inspection, is one of them. We look at the first parts that come out of the process at supplier, and we make sure that they meet the specifications, and if there are any dimensions or things that we need to control beyond the critical dimensions, then we identify a plan with the supplier how we're going to control them. Yeah, it's a widely used terminology, not only within the high-tech industries, but also in aerospace, automotive, in different industries. It's a technique, and it's also not only for the first parts that come in. It's in general, you can do sampling of parts that come in the production at suppliers, and you can look at which parts meet specifications, and if there are any outliers or anything that don't meet specifications, you can define a plan of action accordingly. That's FIE, and then we use other techniques like also statistical process control.
SPC.
SPC, indeed. And that's more looking to the process capability and so on, and making sure that designs are fit for volume production. And we do that with control limits. So SPC, or a statistical process control, is basically a technique or methodology for quality control based on statistics that enables suppliers to monitor and control their processes. Right.
And if I now look to model-based definition, how do you think that can help as an enabler to improve the processes you're talking about?
Yeah, absolutely. I mean, at ASML we do it great. We involve our suppliers in a very early phase in our complex designs, and what we tend to do is we make it all in 2D drawing. We have 3D. We make the TPD, and TPD is technical product documentation, and we do that for so many decades now, 4 decades already, 40 years. We're probably just doing drawings and so on, but we do that from using computers. But instead of making drawings, we can all do that now in 3D and just stay in 3D. So you do your drawings or your models in 3D, and you don't have to make 2D drawings. So that facilitates the digital collaboration with the upstream and also downstream. But mainly we are today focused on upstream, so our suppliers and how they can benefit from that MBD, the model-based definition, for doing all kinds of things, especially quality control and industrializing the parts that they deliver to ASML.
Talking about measuring process, it's a process which actually happens at your supplier's site.
Yeah.
Are you also involved in that process, or you get data out of that process you want to check before you accept the product?
Yes, so we are quite closely involved with suppliers, and we get all the data. We have our own documentation and processes, of course, but it's all focused on also interpreting the data from the drawings. But more and more what we see are the possibilities that MBD brings for all this kind of work. And especially we get a lot of questions from our suppliers. Hey, how can we do FIE or first article inspection using the 3D model data? And that's also why I'm curious today to listen to the story from Mark, to see how their solution answers these kind of problem statements.
We're going to listen to that solution in a couple of minutes, but what is your wish about when is it 100% okay if Mark's work is perfect? What should he do then?
Yeah, that's a good question, a very interesting one. So we want to have all the data in one place and ensure that there's good and quick, fast data exchange, and also make sure that all the data is in one place, like I said, and make sure that all the errors are captured up front and so the parts can be delivered first time right
Mhm.
to us, and then we can build good quality machines for our customers. So it all depends on how good the quality parts are coming in, right? Because crap in is crap out.
Yep.
And so we depend a lot on the good quality parts from our suppliers so that we can deliver good quality machines to our customers.
Do you think that it's possible, maybe in 10 years time from now, that the complete process is completely automated? You define your product in 3D,
Yeah.
and you get your particle back without any human interaction.
Yeah, that is the goal. That is indeed the idea. For me, 10 years is already too late, but
Too late, okay.
but
10 months.
yeah,
Okay,
10 months
Mark?
is too optimistic, but we have to look at solution providers like Polyworks. Maybe we can do it much sooner, much faster.
Okay.
Yeah.
And I believe that's possible, but yeah.
Okay. So, ladies and gentlemen, that's the problem. That's a challenge, actually,
Yeah.
to improve that process in a digital way, to exchange the data on a digital basis, and try to get rid out of interpretation and errors.
Yeah.
That's more or less the shortcut. Okay.
Yeah.
Well, Mark, that's your challenge.
Oh.
What's the solution for all these kind of challenges?
There's no one solution. That's also, you can subdivide it into smaller solutions, like the acquisition, how the data is presented, how the data is captured, and how the requests are made. And those different puzzle pieces of pieces of the puzzle, they will generate a complete solution. But I can understand that for a lot of customers, it's very difficult to implement the complete puzzle at once. So it's really helpful and wise to do it step by step. And I think we have a solution for it.
Okay. If you say step by step before you start your presentation, suggest you need 10 steps. How far are we now on that line? Step 1, 2, 3, 4, 5, or 9? Where are we now?
In basis is that the steps are already taken. Only we can automate the process. So it is the idea that we can gather the data easier, we can share the data easier, and we can share the data which is needed. So we're trying to reduce the number of interpretations, interpretation errors. We're trying to reduce the number of meetings which are needed to get rid of those interpretation errors, and so on. So I think step by step you can improve your process. It's not one step and everything is solved. There's no magical button.
Okay, that's, ladies and gentlemen, a small introduction of my two guests. Now, Mark, you're going to give a small presentation about Polyworks and your solutions. The floor is yours.
Thank you. I have a presentation, I guess. Some help. This is the model-based definition. This is the one I'm looking for.
Yep.
Good. Welcome. First, let me introduce to you what is Polyworks. We are a supplier of 3D metrology software. Not only 3D, also 2D, but our main focus is on 3D metrology software. We are able to use with our software different types of machines, different types of CMM machines, scanning devices, large scale, small scale, and we are trying to exchange the data or distribute the data so everybody can use the data for a proper analysis of their parts. And the easier it works, the better it does, of course. So if we go through the presentation, we go to the next sheet. Like I said before, we are a supplier of building blocks. So there's no, in the process you have different steps. One of them is acquisition, the other one is the request of what kind of data you have. That's what we're talking about today with the model-based definition. But also is the sharing of data and also statistical process control, like Ajith mentioned, and FIE, or first article inspections. That are all different building blocks and how we can get there. The goal is, well, first let me explain who are we. We are Polyworks Benelux. We are located in the Netherlands. We are active since 2015 with 6 employees, and we are a subsidiary of Innometric. Innometric is a Canadian company started in '94 with a global presence about 500 people, and we have an active, direct presence in 21 countries. And if we talk about, if we count also the not direct presence, we are about 30 or 32 countries. Good. Why model-based definition? That's the question we hear quite often. Is it only for ASML or is it only for the customer? what's in it for us? That's the question we often get. The goal of model-based definition is, so if we can go back to the, to the presentation again, no room for assumptions. If you see a paper drawing, you have to look at it, you have to interpret the value, interpret where the stripe's going, and that can leave errors. The other thing is that's the same thing, by the way, no need for personal interpretations, because the interpretation is already done, it's clear, it's based on the 3D model. So you don't need the time for the interpretation. Yes, and eventually it ends up in speed, the processing speed of measurement data. That's the only goal. How the faster we can acquire data, the correct data, and make an analysis based on that data, that's crucial. That's the reason why we are measuring. We're not measuring because we like it so much. We do like metrology equipment though, but it has a purpose. And the goal is to make an analysis based on measurement data. And what analysis better if the data is fast and correct? So, in the end, we are trying to prevent a lot of double work. So it becomes much more efficient and less errors. It doesn't mean that there's no errors, because in the process in the past, when you have paper drawings, there are errors made, and with digital products or 3D models, there will also be errors made. They need to be corrected, so it's not fault-proof. So there will be errors, but there's a lot less room for errors, so you can solve them faster. Good. So to explain a little bit in a real-life environment, we're trying to create we're creating a framework where it applies to. So I'm showing you first a small example of a video on how it is a measurement process is made based on a drawing, and from there on it's taken further for the interpretation. It's a video of about 8 minutes. I think it's quite interesting. I've watched it a few times, and every time I see new stuff, so enjoy.
As a senior application specialist, one of my roles is to prepare inspection projects based on engineering dimensional requirements and analyze the results once the parts are measured. Here, I have prepared a measurement plan to inspect the first 5 produced samples of this part, and I am targeting a portable scanner as the measurement device. The plan includes all the critical dimensions, the measurement steps that need to be done to collect the data, and the inspection report is also ready. To share this plan with my colleague down in the metrology lab, all I need to do is upload the project to Polyworks data loop. Being able to make my work available to my colleagues with a few clicks and without ever leaving the Polyworks inspector interface has completely changed the way we manage our inspection project files. I no longer need to put the files in dedicated folders, keep track of the versions, or validate that the people involved in the process have access to the files. I upload to data loop, and the latest version of the file is instantly available to anyone involved in the process. And as if this was not awesome enough, I can send a direct link, in this case to Jeff, who will be inspecting the samples to easily access the project, and provide additional information if I need to.
Being a Polyworks application specialist means having the privilege to work with almost any metrology hardware that exists. I know I'm a lucky guy. I'm currently working on a project with my colleague Amanda to inspect some sample of this part. She was assigned to prepare the inspection project, and I will be assisting her collecting the data. Oh, it seems she's already finished, and the ball is in my court now. I truly love these direct links to projects. I'm no longer browsing for files and making sure I'm opening the right file, or even the right version of it. I know it might sound lazy, but I don't even need to know the name of the file. I just click the link, and the project opens in the Polyworks Data Loop web interface. So, I'm going to get my hands on it right away.
While Jeff measures the parts, I have customized the dashboard in Data Loop web interface to closely monitor critical dimensions. This will allow me to see the results as they come in and quickly see if any of them are failing or are on an abnormal trend. Now that Jeff has uploaded all the data for the inspected pieces, I can see most of the critical dimensions are good, except on pattern 1, which is failing in all 5 parts. Let me take a more detailed look at this pattern. Yes, now I remember. These are the ones that were challenging to drill. I will alert Matt about this. Matt is the main contact with our suppliers when we need to manufacture parts and has a solid background in different manufacturing processes. He will help us determine what is wrong and what will be the best thing to do.
It seems we have a little issue with the first produced samples. Amanda is saying that some dimensions are consistently failing. Let's see what the issue is. Yes, these holes are not looking good. I was afraid this might happen since our supplier had some initial difficulties setting up the equipment necessary to drill these at the proper location. As of now, we know their position is failing, but to be able to correct this issue with our supplier, I need to know in exactly which direction these holes are deviating and by how much. Amanda is super cautious with her projects, and she's the only one with permissions to edit them. So I'll ask her to include the coordinates of those holes for all the 5 pieces.
As requested by Matt, I have added the values he needs to the current piece, and I can propagate these changes to existing pieces in no time. For the record, whatever Matt told you about me being a control freak is not true. I'm just exploring the benefits of collaborating while being in control of the process at the same time. Let me just add Matt to check these values.
Great! Amanda is so methodical. A dedicated control view. Well, it definitely speeds up the review, and I can confirm there is a consistent trend for the coordinates of the holes. I will tag our supplier so they can access the data and make the necessary adjustments to the process. They will be able to manufacture the next batch of samples with the corrections.
We have received a new batch, a total of 20 new samples to inspect, manufactured after the corrections. Having to inspect a larger batch of pieces, we have decided to use one of our CMMs to speed up the process. I can adjust the original plan to inspect the new samples with it, and the assisted sequencing technology allows me to do this very quickly. I can update the project with an upload to data loop. And now Jeff can have some fun with the CMM.
It seems like the adjustments made to the manufacturing process worked perfectly. The position on the new 20 pieces looks great. Thanks to the values provided by Amanda, our supplier corrected the machine path and was able to get the right position so we can move on to the next challenge.
Yes. Well, you just saw a video where we tried to explain the framework of Polyworks and where model-based definition can be really beneficial. So what we just saw was the measurement request, the sharing of measurement data, but also quickly analyze that specific data, modify it on the request, and eventually, in combination with the supplier, change the part or make modifications, get new samples in and measure them on a different type of machine again. And what is the big benefit for model-based definition in this case? To set up the specific question. Because you have to interpret the data from a drawing, you have to convert it to a 3D model, and then you have to add some data to it and administrative tools like the bubble ballooning numbers, the GD&T stuff, the tolerances. That's quite labor intensive, and it's already been done. So that is a bit wasting of your time. So what does model-based definition mean? We are trying to add that specific data on the 3D model. So in here you see the picture of the part we used in the example, and we are adding measurement data straight on the CAD model. And because of because we are working in this example in a NX software, it's possible to add balloon numbers, the GD&T, the callouts, but even better, you can also use the reporting directly in it. So now we're going to look at the next video, and in the next video it's going to be explained step by step how we can add that data using NX in this example, Siemens NX, and the Polyworks plugin. Here you go.
Throughout my career, I've worked with many CAD solutions and developed solid skills in the mechanical design area, which is why I participate in the design phase of our parts. Typically, once the 3D design of a part is completed, the next step is to proceed with the model-based definition. To do so, I have here a derived part where all the key design characteristics and manufacturing feedback will be defined. I know it's not common practice to add this specification to the same part, but we are exploring a new collaborative strategy. Now, using native tools, I will define the most critical dimensions along with their tolerances. Since this model-based definition represents the single source of truth, defining a control plan from the very beginning will save hours of work for my colleagues who are tasked with handling the manufacturing and the inspection of the part. Using the Polyworks PMI Plus Loop application, which I can access directly from my CAD software interface, I can enhance the native PMI by linking measurement objects to each characteristic. And just like that, the Polyworks measurement objects are added to the structure of the CAD file. And I can review the associated characteristics and assign them a digital unique identifier, which is critical for traceability purposes. As you can see, It is a one-click operation that identifies all the selected characteristics almost instantly, saving me a lot of clicks and a massive amount of time. Finally, saving the part with the PMI plus loop control plan embeds in a single CAD file the native PMI associated with measurement objects where each characteristic is uniquely identified, leaving no room for assumptions or personal interpretation downstream.
Based on my experience with different manufacturing processes, I'm usually the one in contact with our suppliers when it's time to manufacture parts. I know that complementing the control plan with the specifications needed to feed the manufacturing process minimizes errors and the time it takes to set up the equipment. This usually starts with the definition of work coordinate systems that will be used by the machining tool to fabricate this part, which is typically required to associate the characteristics to the proper context. Then, I can add the characteristics that I need to monitor the consistency of the manufacturing process. Here, I will focus on adding the center points of the holes and the midpoint of slabs. And I can do this using the Polyworks PMI plus loop tools directly. Being more familiar with Polyworks than with CAD platforms, this simplifies the process for me. The usage experience of these tools is very similar to their counterparts in Polyworks Inspector. And when I think about it, if your case is opposite of mine, this is a very nice introduction to the way these tools work in Polyworks Inspector. And you are building up a new set of skills without even noticing it. With this, I can say with confidence that the control plan is fully defined with design and manufacturing requirements, which makes this part ready to be released. And if any issues are detected when measuring the pieces, we will be able to correct them immediately, this way optimizing the time it takes to troubleshoot the manufacturing process.
To prepare inspection projects based on engineering dimensional requirements, I can retrieve the CAD model of the part directly from the PLM system, which is amazing because I have access to the single source of truth without leaving the Polyworks interface. So no standalone files or PLM browsing for me. And not only that, but having a direct connection to the PLM gives me access to all the properties, and I can enable the key ones we typically use for traceability. And they will be added automatically as piece properties in the project. Now hold tight, because this is just getting better and better. The essence of model-based definition is creating 3D models that contain all the data needed to define a part. Well, thanks to the PMI plus loop control plan embedded into the CAD file, this means that both design and manufacturing dimensional specifications are part of the import operation and fully compatible with the structure of Polyworks Inspector projects. The formatted report, including the control views, is also automatically added. And from here, all I need to do is focus on defining how this is going to be measured and generating the measurement sequence steps that will be used by one of my colleagues down in the metrology lab.
Yes, thank you. I hope you saw the video about the model-based definition. The idea behind the model-based definition is that you really eliminate a lot of double work, and that I think very much the most important part is you have a single source of truth. We already discussed it a little bit before the presentations or before the webinar, is that makes a really big difference, because you don't have revisions. Well, you do have revisions, but you know you have always the latest one, because you take them out of the same source as the data. So you always have the latest one. And it is clear what the customer asks because he puts it on a 3D model, you will get as well. So there's no room for interpretation errors where that line goes through, or if it's visible, or the resolution of the print is too low, or what else. So no errors because of the wrong interpretation. Well, less. There's always some room for errors. Eventually, in this example, you supported. You saw that Polyworks will be working together with Siemens NX for the plugin for the PMI tools. It will use native PMI tools and will convert them to Polyworks tools because it's a plugin in the native software. It will use combined with Teamcenter, so we can save the data in one file. So it will not be a separate file like maybe if you saw a previous presentation, because then it was a separate file. Now it evolved to one file. But we also will do it with Creo and Windchill, and of course SolidWorks. Good. This was a little bit the presentation about Polyworks.
Okay.
And
thank you, Mark, for this presentation so far. Thank
Yeah.
you.
You're welcome.
Meanwhile, I'm looking if there already are questions in the tool. I don't see questions yet at this moment. But when I was listening to your presentation, Mark, and also listening to what Ajith said in the beginning, talking about responsibilities, I can imagine that you as a customer define a product, a part. You feel responsible for the design and all the additional data which define that part. It gets into this beautiful digitized process. You contribute to that as well. You get your part back, and it's not exactly what you have defined. Who is responsible that it doesn't match? First of all, you, Mark.
Yeah, well, at first, the good thing is we are able to use a single source of truth. So we use the native model, which comes directly from the customer who created the model, and if it's ASML or another company, that doesn't really make a difference. But they created the model, and we're using that model. So there's no issues with revisions or something. So because of that, a lot less errors will be made. Polyworks as a software for a CMM, it's certified, so that's no question about it. But eventually, I think it becomes even better than what it was before.
Okay. And at your side, at ASML, before you send out a file with a definition of a part, how are you sure that that's what you want?
Yeah, so it all starts with having all the information in one place. So now we have the drawing, we have JT, a CAD model, we have other CAD models. There's all information gathered in different places. So bringing it all in one place in a digital environment makes more room for possibilities. So it all starts with that, and there are more solutions. One of them, Polyworks, allows for let's say upstream qualification of parts. So I'm looking more at the possibilities in this kind of applications, and I think MBD is an enabler, also a core fundament of Industry 4.0. So I think more and more we will see such possibilities and solutions that will benefit these kind of applications with MBD.
Okay. In this whole process, because it's digitized, it's all digital, all kind of steps in this process between definition of a product and the manufacturing of that one, data are used in another way as they are there. They are transformed in such a way that they can be input for the next step in the process. Now today we are talking about measuring process. There are a lot of measuring machines, Marks, out there. Do you all connect them?
Well, yes. Well, probably not 100%, but I guess 95% of the CMMs we have a direct connection to. So via direct drive, so there's no software in the middle. The good thing of this is because we are able to use the machine which you already have, and that's about 80 to 90% of the cost. So switching over to the model-based definition is not as expensive as you might think. And the usage of an existing or Mikrocentrum machine or Wenzel machine or even Zeiss machine is possible because we have a direct connection to it.
Okay. If I look to measuring as well with such machines, I must say, the people who work with these measuring machines, do they need different education, training in order to manage this complete process in which multiple disciplines is playing a role?
What you see in the past, if you switch from the traditional machining, like milling and turning, that required a lot of handwork. But then they switched to a CNC machine, and that's different. And then they switched from 3-axis to 5-axis. That's also different. And that's what you can expect as well with a CMM. If you use a CMM as a just for measuring height and some circles, then it's quite easy to use. But if you want to get everything out of it, then it becomes a bit more complex. And you can gradually grow to it, but you need to put some time and effort into it. And that's for everything, I guess.
Okay. You're still improving your tools, of course. That will be continuing forever. What's your next step? What are you going to offer between now, half a year, 1 year, and 2 years?
Well, I think the integration with other software packages will become even more. Interfacing, but also opening up our database so that we as a company add data, but that my supplier and even my customer can look in that same database. So the sharing of data, and it is already possible, but that becomes much more widespread.
Okay.
And I think that's going to be the next step, because the measuring machine, if you look at one of today and one of 10 or 15 years ago, there's not a lot of difference. They become a bit more fast, a bit faster, a bit more accurate, but the principle stays the same. But it's all about data.
Okay. If we look to ASML, maybe you have a wish what he should do first and second and third instead what he's saying himself. What's your first wish to improve that kind of software so your product becomes faster, accurate, delivered?
Yeah, so like I said, MBD, we are looking at getting the products first time right. Also capturing all the errors in the early phase of the design. And I think that's one of the solutions, like with Polyworks, that enables that to happen. But also enabling FIE and downstream, let's say, collaboration, upstream collaboration. I think those possibilities are, let's say, exemplified with solutions like Polyworks. So I would like to see that these kind of solutions come more and more to the market, available for our suppliers.
Okay, so that's your big wish.
Yeah, and in a very short time, hopefully. Yeah.
Okay, I can imagine, because MBD, we are talking about MBD already, let's say, quite some time, but still in the world it's not that big, not big enough. It has to grow, it will grow. Do you have any idea about the time frame in which you can say 80% of the industry has also based its processes on MBD?
Well, I guess it can go fast, but indeed, PMI does already exist for 15, maybe 20 years. It's being widespreadly used in aerospace and automotive. But you need to change some processes within your company. And if you're doing the same thing you're already doing for 20 years, then you will not become more efficient. So take the step. Dive into it.
Just start,
Just
start.
Do it. And of course, everything costs money, but the costs are not so high as that you might expect.
Okay. So you have to do it. Just let it going.
Indeed.
Okay. Okay. Well, gentlemen, I'm going to look if I see some additional questions over there. Does Polyworks checks the consistency of PMI annotations accordingly to ASME and GD&T or ISO GPS, or do you need other software to that?
Well, that's I think that's somebody who already knows Polyworks, but yes, that's what they do. It will check the accuracy of the PMI which is coming from NX, in the example, if it is correct or not correct.
Okay. Okay, fine, thank you. Let's see if there are more questions now. I'm looking to my colleagues. I don't see any questions from the audience at this moment. By the way, if you have more questions later on, also put them into the community, because these gentlemen look over there in the community and we'll see if you have additional questions tomorrow, the day after tomorrow, or next week, and share knowledge and opinions about that. So you'll keep on track on also these questions in the community. Another reason to stay there, ladies and gentlemen. Okay. Then I'm going to thank you for this moment, Mark and Ajith, for their contribution to this event online. Thank you for that. We are not finished yet, because now we're going to have a look at a next event, and maybe I want to have that slide as well on the screen. Okay, that's on the 9th of December, ladies and gentlemen, on the BrainPulse Industry Campus in Eindhoven. Then is the MBD Solutions event. You're all invited to also be present over there. And as far as we can see, the COVID rules are meanwhile that low or even disappeared, that you can join in person this event. You are very welcome to be there and I would say join this event and exchange knowledge, ask questions to the specialists, and you'll get your answers maybe on that very day as well. So the 9th of December, put it in your agenda already. Okay, then we go to the next slide, and that's actually the closing down of this event. We are going to thank all people who have logged into the tool, in the community tool, and joined this session. Again, Mark and Ajith, thank you for joining this event and talking to the audience. And if you have any questions as well for the audience, you can also put your questions in the community, of course, because it's a bi-directional exchange platform, not just one way, but two directional for you and the people who are already in the community.
Absolutely.
For this moment, dear attendees, thank you for being with us this afternoon, and hope to see you soon, even on the 9th of December or on another online seminar. Keep track on our events in the community. Keep safe.
Okay. How'd it go?